mechanical engineering. We want to know what the status of additive manufacturing in mechanical and equipment engineering is, and what the current trends and in terms of materials, processes, and application. With me in the discussion today is a top-class circle of the industry with an international background. I'm accompanied in the studio by Dr. Markus Heering, Managing Director of Arbeitsgruppe Additive Manufacturing in the VDMA. Hello, Markus. Good to have you here. Thank you so much. Digitally connected to us are Dr. Alba Mena Subiranas, who is Vice President Maintenance and Reliability Solutions at BASF. Welcome, Alba. Then we have Douglas Woods. Doug, you made it. Perfect. Thank you so much. The Association for Manufacturing Technology President. Then we have Franz Bosbach, expert for technology preview at KSB. Hello, Franz. And then we have Dekker, President of Met-L-Flo and President of the Additive Manufacturing Users Group. Hello. Good to have you all here on board. Together with you, we want to have a look at the level of maturity of additive manufacturing in the industry, whether the market valuation of some company is really justified, and whether we are really talking about mature processes. So I'm particularly interested in which application you probably brought with you and can talk about, and where there is still potential. So let's start. Alba, if you don't mind, I would start with you, if you don't mind. So it's a pleasure to have you on the panel. Quite exciting. Additive manufacturing and chemistry, where are the connections and the areas of application in your field?
Yeah, even if BASF is a chemical industry, we have a long tradition and knowledge on the manufacturing area in welding, milling, drilling, and so on. So for us, the additive manufacturing is just a complementary manufacturing technology. And regarding our areas of application, perhaps we can classify there in three groups. Now we started with the topic of spare parts. So if a provider is not able to supply us with a spare part in the right delivery time, then we can print, of course, the part. But then we move to a second group of use cases or application areas, what we call design optimization. So we look at the part and we look at the function that this part has in our production plants, and then we try to optimize the part for the needs, our specific needs. So this is the measure area of application. And the third one, it's also regarding repair. With LMD technology, it's also possible that parts that have abrasion, for example, that we can repair them via additive manufacturing. So these are our main three areas.
Great, thank you so much. So I may introduce last participant I just forgot to mention. Travis Egan, you are also on the panel. Thank you so much for joining us. AMT's Vice President of Business Development. I'm happy to hear your insights later. Thank you for joining us as well. Great.
Thank you.
Carl, I mean, you have been in industry for almost 30 years. What is your current role, and at what TRL level is the technology when we talk about the use of AM in engineering? Because you came up with an interesting thesis here.
Well, I mean, my current role is obviously president with Met-L-Flo Incorporated, contract manufacturer. So we're providing parts for people to use and put into applications. Also participate as president of the Additive Manufacturing Users Group, because trying to help further the advancement of the technology and the capabilities that it has, and getting people together to share. Well, getting people together is a challenge these days, but nonetheless. When you ask about the TRL level, I think we're pretty much at a point where a lot of the technologies meet the criteria for application from a TRL level. I think we've got probably more issues when it comes to the MRL, the manufacturing readiness levels, because we're dealing with some of the systems that can be very challenging to get repeatable, reliable, consistent production out of. And now how do you get a new installation set up, functioning, and capable of producing end-use parts? And going back towards what Alba said, She mentioned the design consolidation and a lot of the paradigms that need to be applied to make manufacturing with additive more successful and viable economically as well.
Great, thank you so much. Markus, welcome back here in the studio. Explain us, what do you do at VDMA and what is your focus topic when it comes to AM and its use in mechanical engineering?
Yeah, you know, VDMA is the association originally was from the manufacturers, different industries, different sectors. And Additive was established a couple of years ago with some different tasks. One, of course, is we offer a network to the industry, to the AM industry. That means we include not just the AM machine manufacturers, also the users, the service providers. We include the material suppliers, research institutes, so complete network. And we work together then with governmental organizations, research plans, and try to inform then what is the current status of additive manufacturing. Second task is, of course, integrating additive manufacturing in industrial procedures was one of the first ideas, and there are a lot of things to do. We work on a roadmap, we work on machine-to-machine communication to offer the opportunities to integrate them like typical tool machines in industrial procedures and in process steps. And the last point is, as additive manufacturing group, we are a little bit an information point for the other members of VDMA. So we are the neutral information part where they can receive information about the current status of the industry, how they can use it, what are still the challenges what the industry have, the technology have, and this is the third point. And I guess altogether shows a little bit what we are doing at VDMA.
The last point is really interesting for me because due to the crisis, we have discussed that we experienced kind of a boost in additive manufacturing due to the specifics. Do you experience more requests in order to consult companies if it comes to AM? So are more companies reaching out to you and asking you, how can we implement AM in our processes?
Not more. I would say it's more or less the same level. Okay. What we recognized before is that still round about 70–80% of the machine manufacturers in Germany know a little bit about AM. Some of them still implemented then in the machine park, what they have at the facility. Some uses external service providers, but most of them are a little bit familiar with AM and what they can do with it. Of course, you still have sometimes ideas, and I have to say most of the ideas come from authorities and governmental organizations. They come to us and say, could that be done with additive manufacturing? And members was just a few what coming up with this topic.
Interesting, interesting. Douglas, question to you. We discussed this interestingly in our pre-round. At AM, we are still talking about a comparatively small market around US, I think it's like $12 billion roundabout. But there are much higher company valuations, especially in the US. Carsten Heuser of Siemens spoke this morning of an industry tipping point. In your perspective as president of the Association for Manufacturing Technology, do you agree? Is there now a tipping point in additive manufacturing?
Yeah, I think he's exactly correct. If you look back when I got into it originally as a manufacturer, it was back in the late 1990s. So additive's been around for a long time, but you look at what's happening now, and you just see this massive growth. And massive growth is really being fueled by some of these enormous evaluations for the companies. Desktop Metal recently, at over $2.5 billion. And you start to look at what those kinds of resources could do for you from an investment standpoint. So if you now had hundreds of millions of dollars, you were able to invest in researchers, material analysis, developing new equipment. This is really an enormous step forward in what you can do, accelerating kind of exponentially the development of the additive technology and getting it into broader applications in the marketplace.
Great. Franz, responsible for the technology of the future. It's quite a position and it's quite a responsibility, but you work in a really very old but also very successful company. And I remember when you introduce it, and you should introduce it now because it's really impressive, where do you apply AM in your business, and how far does this application go in practice? But probably please include a little bit insights about your product.
Okay, yes, we make since 149 years valves and pumps. So all industrial revolutions from 1.0 to 4.0. And we started about 18 years ago with additive manufacturing in metals. And for us, it's now a part of our foundry, where we can produce spare parts and new parts within a really short time. And it is really important for us that we have the flexibility, especially in this crisis at the moment, to choose the right production technology for the parts we are making. So it will not skip all other production procedures. It will be an additional part of production for special designs. We need to know, we need to develop these designs, but on the other hand, we already know there will be new materials available which we can't get in forged or cast. So these qualities will be available in a few years, and in the moment we are really in production for our standard products. And that was perhaps a difference for most other companies. We were going live with additive manufacturing metal parts in our standard business and not spare parts, since spare parts is 100% additive manufacturing. And parts within our products, we can organize quality and reliability for our own. That was a difference.
Great. You just mentioned materials. Markus, let us talk quickly about materials. Metal, plastics, ceramics, where's the most happening right now from your perspective?
I would say in metals. We have seen a lot of new products, a lot of new materials what are now used, and what the technology is able to use and to produce. And I see also for the future the biggest development steps in metals. In the structure, you can do a lot of things with amorphous or crystalline structures with the cooling curve, and that is what I expect in the future, that we do more and offer complete new materials what you can't produce in a typical way. I see a lot of possibilities and opportunities in this field.
Great. Carl, I mean, you're a lot into metals. First question, would you agree on what Markus just said in terms of future focus? And in this term, the second question would be, how important is it to establish standards in the industry?
Well, I think what Markus was stating is very correct. There's the ability to be able to customize materials, customize structural grain properties, customize it for the geometry is amazing. How to design for that, how to be able to control that in a process is another challenge, but definitely a lot of potential there to make things that couldn't have been made before. So when you ask about standards, that definitely becomes a bit of a critical point on this, and that is, standards are basically how do we make it easy for a consumer to communicate to a producer what they need manufactured and make sure that it's produced on a regular, ready basis. And also from a broad scale, how does that apply across an entire industry platform so that it doesn't become a single point source? Having these standards in place allows people to be able to call out or specify the how to manufacture something to be able to get the correct intended end product from something without necessarily having to do extensive qualification and verification at each and every site or location to make sure that you're getting the right product. So standards are definitely an area that I think will help advance the industry and make it a lot safer for people to be able to buy product from a collection of distributed manufacturing sources around the world.
I mean, we are talking in an international round and we were speaking of standards. How's the communication between the continents about standards? So is there communication between the US and Germany when talking about standards? Because this couldn't be something in such a small community, worldwide operating, that you decide in one country. Markus, what is going on the standard side?
Yeah, it's absolutely necessary to do that in an international way because the conditions are the same. It doesn't matter if you're in US or in Europe or in Asia. Therefore, we need standards at all. They must be valid global. And we had also at last Formnext, what was physically in Frankfurt, we had a meeting where the international standardization groups meet each other and have spoken with each other. And it doesn't make sense to do it in double wise, so we have to do it together, and that is what we started and still do.
Great, great. Douglas, you mentioned the high evaluation of companies and a lot of money, and you put it in a positive way, which I like very much. Thank you for that. So we have all this money. So which process step in additive manufacturing still needs the most optimization where we possibly could need the money for? Or Travis, I mean, I don't know who wants to answer that question.
I'll try. My good friend Travis has been standing in for me because I'm at a cottage in the Cotswolds hoping to get closer to you, and I have the worst Wi-Fi in the world, so nothing against the Cotswolds, but Travis is here in case of emergencies. But to the point of your question, my CTO would answer the question qualifications and process control, and he would really focus on those. For me, I'd really actually turn it back into the point about the investment, that the investments really need to be turned around into being able to really get to production-ready technology. So additive technology with the materials, with the processes, with the equipment needs to be simple and easy and reliable to use. And so you need to be able to take these investments and really ensure that these investments are accelerating the production-ready level of the equipment for the mass market. And hopefully that's what we're going to start to see happening, is that the focus really is on how do we get the right types of equipment out that are easy for the end users to apply. So when I was running my company, it was a $20 million shop. And so you only have a certain amount of technology and capability. There's an expectation that the OEMs are going to deliver bullet ready, kind of ready to go technology that you can use. And I really think that's what you have to hope happens from these large amounts of investment that they currently have.
Great, thank you so much. Alba, quick word to BASF. Spare parts are already printed 3D in large volumes, as far as I understood. How many components are there, and how is quality assured? How do you assure the quality afterwards?
Regarding the amount of components, I can say we started 4 years ago, more or less, and at the moment we are printing about 4-digit amounts of parts this year, metal parts. But printing is one thing. I think the important thing is that all these parts are in operation. It means they are in operation in labs, in pilot plants, or in production plants. And to the second part of the question regarding quality, safety and quality are on the top of the agenda of BASF. And I think we are lucky within BASF because we have a lot of competencies in-house. So we have a quality assurance program in place. But for 3D printing, it means we have design, simulation competence, we have a quality program for the printing itself. But after that, we also have material and testing know-how that we can use here directly in-house, as well as a notified body here in-house as well. So we can assure the quality along the cycle of a 3D printed part. And on top of that, we also work very active in committees for standardization, especially on the area of pressure equipment, who has higher standards. That's also important for us to achieve these standards for our applications.
Great, thank you. Leads me to Franz again. Franz, I mean, when we're talking about quality of your products, I would say this is the most important topic. How do you handle that? You need to fulfill highest requirements. How do you ensure that requirements are met? Because you can't do it afterwards. Once you delivered your product, then it's a little bit too late, I would say.
Yes, and that is amazing for additive manufacturing. So we have the first time in history the possibility to have a picture of each slice of the product itself. So we can make pictures by production. And as we are really next to our foundry with our material experts, we are used to make probes for tensile testing, sharp node testing, and so on. So we have all the capabilities to test all the additive manufacturing parts similar to casting. And so we can assure also the quality similar like the casting processes. And there it's common to have to each found to have a probe for testing. And that is what we also introduced in additive manufacturing, that with each print shop we make test specimens to analyze if anything is going well in the production. Additionally, we have a much more data from production part. We can ensure much higher quality in each area of the product. So the frequency of errors is much more less than we have seen in all other production areas.
Great. Karl, if you hear all that, I think the process has changed tremendously if it comes to quality assurance. It's happening a lot earlier than in the past, where you have the finished part, or at least a prototype, and test it. Now testing comes in the very early stage. You do a lot of, I think, based on experience. I mean, you are 30 years in the industry, you have your own company running for years now, but is there enough people coming after in order, so young people interested in the AM industry, so that you have enough people to fulfill the requirements in terms of human resources in the industry?
The level of interest that's coming out of university is tremendous. It's great to see all the excitement and everybody really looking to jump right into the technology. It is a bit of a challenge when you look at them coming in. Unfortunately, their knowledge and experience level is fairly small compared to what they need to apply to all the different technologies. But if you've got the right mindset, it's a lot easier to teach somebody. So that's very encouraging. But it is an area where there's a lot of growth needed. There's a lot of development needed. I think there's a lot of universities that are doing a great job at getting people with awareness. But even with additive, there's still a whole collection of things, just like what Franz was talking about, where you have to inspect as you're going along. You need to understand your GDT requirements, how you're going to qualify and validate that the end product is actually there. And if you're giving a student an entire selection of classes on additive manufacturing, the technologies, you still need to backfill that with standard manufacturing practices. So it's excellent for being able to get students involved, being able to get that excitement going. But there's still a lot to be taught and a lot for them to learn. But it's a lot easier to teach somebody who wants to. So.
Yeah, so true, so true. Douglas, I mean, this is probably one of your responsibilities to bring the message to the market and probably to cooperation partners as well as the VDMA, right? I mean, are you talking to universities from time to time, or to persons who are responsible for educational offer in order to push a little bit the young people to step into the industry?
Yes, I mean, it's exactly what we're doing. We coordinate with the technical community, colleges, actually even high schools. We have programs where a lot of the fundraising that we do on different programs, whether it's a fun run or something we do from one of our major events, where we donate additive equipment to local high schools in different parts of the country where we're actually doing our programs. So it's everything up to universities and working with agencies, our Department of Energy, Department of Defense, making sure they've got programs and connections right through from credentialing people initially getting into the industry, but also then coordinating with some of our innovation centers. So I think it's definitely something that there's a good pattern built here in the US, and I think things like the maker movement that have gotten a lot of young people already 7-8 years ago interested in additive, interested in manufacturing. You're seeing that blossom as those people then move into how they technically be more involved with the industry. So we're very fortunate to have a high profile technology like additive manufacturing in our space because I think it does draw in younger people and good engineering talent.
Alba, how is it at BASF? I mean, you are coming with a new technology. As far as I understood, you're optimizing your current production. Do you have the right people in place? How do you find them? And is there sometimes an argue between the traditional engineering or chemist? I don't know the proper word for that. You know what I mean? Is there sometimes an argue between the one that wants to implement the new technology and the one that wants to stick to the old procedure?
Yeah, I think, as I mentioned, once we started 4 years ago, we went to the up and down process, the typical change process, because some of the craftsmen were afraid that additive manufacturing will replace completely the conventional manufacturing technology. Now we are at the point that we see all the people, including craftsmen, they see it's a complementary technology. Regarding acquiring engineers, as Carl mentioned, the interest level and excitement level on engineers level coming from the university is very high. So at the moment, it's relatively easy to get talents. On the craftsmen and technicians arena, we have to build them by ourselves. We have here in Germany this apprentices model, so for mechanical jobs. So now we are building on top of that a module especially for additive manufacturing. So kind of upgrade of the current system that we have.
Great. So I promise the last question on education to Markus, because in my opinion, a very, very important topic. I mean, we're talking about a fast-moving, highly innovative industry. And I mean, you're highly dependent on people coming next in order to support you there. How do you keep up the speed in the development of an industry in balance to the speed of studies and education, because they study probably already old content when the industry is much further.
That is always a challenge, what you have in new technologies. But I guess the biggest challenge what we have with education and additive is to implement that in universities on a common level. That means if you hiring a mechanical engineer coming from university, you must be sure that he knows a well-known level of knowledge, and it doesn't matter from which university he is coming. So you must have a common level of education, and that is what we don't have at the moment in Germany, and I guess at all not in Europe. Each university, or most of the universities that are active in mechanical engineering, they have some institutes that are working in additive manufacturing. They do some research, they do some developments on a real high level. But it's not integrated in the study at all. That means you can hire a mechanical engineer. He has never heard during his studies about additive manufacturing, and that is a problem. Yeah, and that we have to solve first, and then we will have always some niches where you go deeper in. It can be process engineering, or it can be construction, or it can be additive manufacturing. And I guess in that point, we are sure that we really have the institutes that have the highest level of knowledge. That is still the case now. But this common level of engineers that have a basis information and a basis knowledge of additive manufacturing, that is important, necessary to do. We raised that several times at German ministries. The challenge in Germany is we have the countries, and education is under the umbrella of the countries. That makes it so difficult. But this is, for me, the challenge at universities, to have this common level and knowledge. That is what we need.
Great. You're so Absolutely true. Let's step into the questions from the audience, if you don't mind. I will start with one from Karen Feinberg. What kinds of strategies do you suggest to bring more diversity into the pipeline across education, industry, business association, and immigrant communities engaged? So I don't know, probably Douglas in the US, what are you doing to support more diversity in the field of AM?
I think it's not just actually, frankly, AM. I mean, it's a practical reality that we have in manufacturing across the board, manufacturing technology, that we need to get enough new people interested in our industries so that we can continue to prosper. And for a long time, there wasn't a lot of women, there wasn't a lot of minorities, there wasn't a lot of people coming in from different ethnic areas. And so largely, again, what we're doing is starting down at the grammar school and high school level, getting people excited and interested in the technology. And again, if you have a lot of these new transformative technology, we're talking about additive, we're talking about augmented reality, we're talking about generative design. Some of these new technologies are really quite fascinating to younger people, and that younger people goes across all the different types of diverse folks that you'd like to have involved in your industry. And so to the extent we can continue doing that, to create these opportunities at younger levels where they're excited about these new technologies and can see a career path that is interesting and fun, and there's really no limitations. There's no limitations, especially when you're starting in at those younger levels. I think you've been, by natural period of time, are going to get a lot more interesting, diverse folks involved in our industry.
Yeah. I totally agree, and especially on FOMNext, remembering the last year, you could see that a lot more startups led by women, for example, and from different cultures and origins, because it's mainly based on creativity, looking for the right solution, and I think this will bring us more diversity automatically, probably, without any further strategy. So, a question probably to you, Franz, from James Reeves. There was a comment that certain parts cannot be cast. Did that statement include additive casting? Where does the panel feel that additive casting, like printed molds or patterns, will go in the future, and how could it impact direct metal printing technologies? So either Karl or Franz, please.
So in this case, we have mold printers live at the moment in different foundries at KSB, and we see, of course, there are different possibilities. And if you really go to really small dimensions, to 0.1 millimeters down, really small structures, heat exchangers, and so on, we won't cast that. So that is a standard domain of other manufacturing parts we now can make directly out of powder. And so, of course, you have fine casting and so on. And the corners this is a little bit complicated to say, okay, is this just for this technology? So most parts we can do by different technologies, but sometimes you have limitations of time, of quality, and so that depends, and that is why we say, okay, it's one new production technology to bring up this part and additionally to the others and not as a substitute.
Great answer. Thank you so much. Karl, I need to get back to the diversity topic again. This is, I'm pretty sure you can answer that because you, in my opinion, you are a role model to that question. Because you are 30 years in the industry and still top of the, you're fully up to date, you are leading the innovation in your field, and you are supporting the industry to grow. This question is about engaging those older generation from those that worked in old school manufacturing, and now they are switching over to this new manufacturing techniques. How do you see that? Is there, for the classical mechanical engineer doing this for years, is there space in your industry, and how can we integrate them?
Well, first of all, thank you for the compliment. I hope that I'm trying to stay on top of things as much as I can. Every day is a new learning opportunity. As far as how to help the incumbent workforce, that's kind of an ongoing challenge because you're dealing with different paradigms, different skill sets, different ideologies of how they want to proceed and move forward. I think that really the safest way is to get them comfortable with the technology. And the rapid prototyping, the design, validation, design guidance side is an excellent way to move forward. But I think that if you can help them with getting it into jigs, fixtures, components that are used in the manufacturing process or manufacturing aids, you can get more of that comfort level, because we're dealing with a workforce. I'm not trying to say anything negative, but that started with stereolithography, and the common joke was you look at it twice and it's broken. So we've come a long way from that. We don't still use the same brick cell phones. We don't, a lot of things have advanced, but if somebody encountered one of those situations, they may have turned away from it and stopped watching or staying on top of the technology and no longer are up to date with what's possible. How do we get them to comfortably embrace it and get organized manufacturing assemblies or manufacturing plants to be able to engage it from a cultural standpoint, so that they're not afraid to take it to the next level and actually apply it to more end-use components. So I think it's one of those where you have to slowly get that comfort level established to get them moving forward. Kind of going back towards the educational that everybody was saying, it was great to hear what Doug was mentioning about getting it into early education areas. How do we get some sort of a national strategy to get that awareness? Because getting the current workforce to understand how to do it is a lot easier if you have new workers coming in that have a proper understanding and can actually help support that technology and kind of be that champion to help make it a success. That might help give it a lot of opportunity. And again, the technology is kind of new and continuously evolving. There isn't any predisposition towards anybody on how you can apply the technology or what sort of background you have to have. Everybody's learning it at the same time, so there isn't any predisposition to any birthright or anything like that would cause somebody to say, oh, I'm not going to listen to them because of that. No, it's new technology that a lot of people are learning all at the same speed. Getting that into the current workforce is an ongoing challenge, though.
Great, thank you for the answer. Brings me to a question not from the audience, but that I experienced in a talk with a person from the automotive industry. He told me that it's difficult for the new engineers coming up, for example, to do reverse engineering because they are not used to the old drawings, to the old part descriptions that we have today. So there is, I think, enough room for bringing together old and new mechanical expertise. And it's like in all other business fields, basically. You need to do kind of reverse coaching in order to make the young guys clear that there are a lot others with much more experience who can teach them something, and the other way around the same way, right? So we have another question. Considering the current trend, what's the major correlation of AM and lightweight design for components, specific task in the manufacturing industries? So lightweight design for components and AM. Markus?
AM is one possibility for lightweight design. It depends in which using case you would like to use the product afterwards. So it can be done by composites. It can also be done by AM with structures, with bionicle structures. It depends, but I would say one possibility for lightweight design is additive manufacturing with different materials, and you can use it then. But we have others, so that's always the case. The question in which case you would like to use the product afterwards.
So it's depending on application.
Yes.
Okay, great. Thank you so much, Markus. Probably Douglas or Travis, what industries could serve as a model for additive in striving to be production ready from a process, quality, and particular materials perspective? Semiconductor comes to mind. So
let's let Travis get to play a little bit since he joined in for this session.
Sure, thank you. Yeah, I think the semiconductor industry is a prime opportunity for additive manufacturing. There's a lot of benefits to additive that are above and beyond what you can do with some of the traditional processes. So, take for instance the ability to sort of embed circuits or sensors into a metal part or a plastic part. And so when you look at semiconductor in particular, that's a tremendous opportunity if you can actually put the electronic component or sensor into the product itself. So that would be a great one. Great example.
Cool. Franz, one question we haven't talked about, and I'm really interested in. Let's talk a little bit about size. I think the parts you are printing, how big are they, if you print them?
At the moment, of course, it's limited to the size of the powder bed, and so that is a limitation at the moment if you have the powder bed-based production areas. But we see now robot-based additive manufacturing directly from powder or wire, and normally our products are much bigger than the 800 millimeters we up to now were able to print in powder bed. So I think in future we will see much more robot-based, and then we have a hardly unlimited space. Of course, we have to handle it later with all the different possibilities to make the material in the high quality. But on the other hand, we see at the moment printing buildings in the size of 20 meters in concrete, but if you compare the technology itself, it's the moving of the parts, it's the same. And so we will see much higher, bigger parts, and our products are up to 20 meters long, as if you have an intake pump for power plant, for example. So the small helps us a lot in spare parts and small pumps and valves, but normally the really interesting bigger parts we do not get at the moment into the printers.
Okay. Carl, I mean, you are producing such parts. What is the biggest size you could offer to Franz then?
Well, as Franz was saying, if you're looking to take a part that's qualified directly off of a machine, you're limited by the capacity of the machine. And just like he was stating, when you get into robotic systems, you open up a wide collection of different ways to make larger parts. But I think that you need to look at the different techniques that you're trying to, the different application that you're applying, because the fused filament fabrication parts, we've made a number of those which measure in like a dozen feet, but they're assemblies. And they're done that way so that they have manufacturability by the equipment. They also have manufacturability for interchangeability and adjustments and for adaptation for future modifications. So there's a lot of different strategies that you can apply there. I think really the end game comes down to what is your volume of manufacturing. Because if you're only going to do a few parts, then yes, doing something like Franz was stating with a robotic arm may be the most effective way. But if you're eventually going to ramp up to doing 4 and 5 or 6 digit volumes, you still need to test the production process. And making it through additive may not actually benefit you other than getting through the design development, design validation, design guidance phase.
There's one question fitting perfectly to this, what you just mentioned, from Philip. Could we get some reliable numbers in terms of output regarding printing parts from use cases? So do we have use cases where we've seen a large number of parts right now in the industry?
Yeah, we have some. We have some samples. We do always a survey twice per year with our members in Additive Manufacturing Group and asking them what for they use AM. And we see we have, not the majority, but we have some what are producing a high serial number of products based on AM technologies. Yeah.
But can you mention a specific example or?
It's difficult to say based on that survey. I know we have some members what are producing for special drilling machines, the plastic material, the outside based on AM products, and others sometimes for internal products. But it's difficult really to face. I would say the common case is still a volume 1 to maybe 50.
Okay.
Not the big ones, but we have some what really do it in serial production, yes.
I think this question will accompany us for some more years, I guess. Nothing we can prevent. There's another question from Dr. Lukasagi. How do you see the future of AM in the oil and gas industry? Is it possible to do it nowadays, or do we need to wait the advance of tech to produce larger parts? I mean, it could be a pump-related question, Franz. How do you see that? Is that something you're already into, or?
At the moment, yes, we are discussing with oil and gas industry, especially in Canada, to see, okay, can we do the design, for example, in the back offices in Germany, and then send the data and print it in a print shop in Canada. And especially we have in oil and gas a part of really high wear parts, and normally we send a new part after 8 to 12 weeks. And so if you send tons of material every few weeks out in the outback in Canada or Russia or anywhere else, that is a high challenge in logistics and so on. And if you can say, okay, we can print different sizes locally with the design of the original equipment, that is something we're really starting. We are discussing with different companies at the moment, but at the moment, I would say that's upcoming and not really live, but it's really interesting business case, yes.
Okay. So Alba, probably a question you can answer, because this is really interesting. From Kai Wen is asking, if you look through the job market, the demand for mechanical, electromechanical and IT engineers in the additive manufacturing industry is higher than of material science. Is it because material development is still inferior to the construction of instrument in priority? So is materials less important than perceived as still the process, or?
I wouldn't say like this. I think they are equal important, no? Because without material, you don't get any part printed. And if the material doesn't provide the right quality in particle size, whatever, then you don't get the appropriate part. So I would say the demand is at the same level. Materials engineers, mechanical engineers, IT, automatization, all of them are required at the moment in the industry and will be also in the future.
I guess maybe it's coming from because all the industries are looking for IT experts. Because IT is a question for all industries, for mechanical engineering, for automotive industry, for the aeronautics industry. It was always a question a couple of months ago. So all the industries are asking for that. We have a lack of educated people in that area. And I guess therefore it's coming the feeling that maybe especially in additive there is a special need for them. No, the need is in each industry.
Okay, so the focus is there of the need. Okie dokie. Let me see what we have else. There's a very specific question. I hope somebody can answer it. Anyone on the panel have experience with cellulose nanofiber or other wood or cellulose powders? Anyone? No.
No, not really. I know that some...
Fair enough.
Some researchers doing on that, I know that, but I don't know details and what is going on there exactly. It's a small niche, of course.
Absolutely. Douglas, one other question to your direction. Are you having a strong focus on the US in your work? I mean, of course, because your society is focusing on that. But where do you see the current trends in the US if it comes to mechanical engineering in combination with AM?
Yeah, we do have tech facilities actually around the world, but obviously our focus is on manufacturing base in the US. And most of the engineering schools, Carl's probably seen this as he looks at the industry as well, a lot of them have made the advancements already in positioning their programs to really start evolving engineers into the current, whether you want to call it Industry 4.0 or this digital transformational space. So the transition's already really largely been happening, and getting mechanical engineers from what I remember when I was doing engineering quite some number of years ago to today really being much more, I think conversational in all topics, digital. And so digital transforming into this actual, if you're going to be a good mechanical engineer, you've got a lot of crutches now. So you can leverage generative design, you can leverage augmented reality, you can leverage a lot of different technologies to kind of help you do things. Even when you look at additive, engineers can dream up something that couldn't have been made 25 years ago very easily, and actually now it could be made. And so when you look at also the type of person that could be an engineer, you really had to be very quite, at the top of your game in mathematics and certain, thermodynamic capability. Today, some of these digital tools can help you. So what you can do is now get a much more creative side into engineering, which wasn't really possible, 25 and 30 years ago. So you can take people that are art students or good creatives, give them some of these digital tools and help them to be really good mechanical engineers, but in a much more innovative space than what we were able to do quite a few years ago.
Great. Carl, at the beginning of our panel, we discussed a little bit standards, and there's a question from Drew. Do you see much of a regulatory framework in the US market in terms of oversight and standards for materials?
As far as regulatory, I wouldn't say that the government is necessarily putting in those standards and requirements. You may have things like FDA or FAA putting in standards and requirements based on that, but a lot of them are working with the standards development agencies, the SDOs, to try and help direct some of the standards development activity. It's really interesting how much collaboration we've seen from the 13 different standards development bodies here, the integration of the ISO TC 261 with the F42 and all these, the American Makes, AMSC activity. It's really exciting to see how much collaboration is going on to help develop and advance a lot of these ways of thinking and ways of applying standards to the manufacturing process. But again, it's still a volunteer army. So it has some limitations, but it is definitely one of those that is probably moving faster than a lot of standards have ever moved before. And it's excellent that the ISO has been engaged with them, because it's now incorporating Asia and all other parts of the world. I think there's 23 countries that are active participants in the TC 261 group. So it's nice to see that we're not going to, it's hopeful to see that we're not going to have a bunch of standards that develop individually and isolated by regions and areas of the world, and that we can all kind of speak the same language on that front. So.
Is there a direction in terms of standards where they consider all parts of additive manufacturing at once? So it means material, processes, hardware, etc. So like an overall standard in terms of that's how a process should look like? Or?
No, it will be difficult, because we're speaking of a huge variety of different processes. We're speaking about thousands of materials. It doesn't make sense to put it together. So you have to split it, you have to separate it and to look to each other. Otherwise, it will be nonsense.
Okie dokie. So I would like to use the last 4 minutes of our panel discussion that everybody can give a quick statement on what topic we're going to talk about next year at Formnext. What will be the key topic for next year? And I see all the exciting faces keen to answer that question. Alba, start with you. You were the one to open this panel. What do you think will be key topic in mechanical engineering next year? Take your time.
The consolidation of the market, of the additive manufacturing market after the COVID situation or the economic crisis.
Okay. Franz, what do you think?
What about glass and ceramics in additive manufacturing?
Okay. Carl?
Well, I think we're still going to have a major topic associated with the workforce development and education, because we've now made it possible for a lot of students to get access to a technology that can manufacture anything. But a lot of the education has eliminated what used to be called shop So they don't have the need to look at all of the GDT requirements. They don't have the need to look at subtractive technologies. And the one question I see coming up a lot is, should you 3D print it? Can you? Yes, you can 3D print anything. But should you? Sometimes it's easier to use subtractive or already conventional technologies to be able to manufacture something. So I hope that we don't wind up creating a workforce that is too myopic onto 3D printing and lose capability to embrace all manufacturing to get good products.
Very good point. I hope it too that we don't get separated after a while. Douglas, what is your statement?
I'd say hybrid manufacturing. I think there's a huge amount of investment happening there. I think it's something that's dynamic and a lot of ways to help the production readiness of the components that come into the marketplace.
Great. Travis, what is your opinion?
I would say that it would be in the area of production for additive manufacturing, the continued speed at which we go further and further into the production area. And I think a lot of that will happen to coincide with transformative technologies. You know, it's a digital technology and machine learning, artificial intelligence. These sort of technologies will help speed the market development for additive manufacturing.
Great, thank you so much. Markus, you have practically a minute.
Yeah, I try to do. What I expect is that we still will discuss about the automated procedure from beginning to the end. That the procedure is running really automated, that there's a machine-to-machine communication from the AM machine to the finishing technology, and that must be run in the future completely automated. And we are working on that. We started that, and I expect next year we will be a step ahead, and we will discuss about this a little bit more, and we have some more details and some more facts on that.
Great, great to hear that. I think we had a perfect setup here because it was mechanical engineering is a broad field, to be honest. I think it's the broadest panel we have. I think we had excellent participants. Thank you so much for sharing the insights, for answering the questions out of various fields. So I think we covered a lot. I think we could take out some key points, and I hope the audience as well could take something with them. Thank you so much for participating here at the mechanical engineering panel. It was a pleasure to have you here. Good luck, success for the future, and enjoy the rest of the FOM Next. Thank you. See you soon. Bye-bye.
Bye-bye.